Slide 33 once again shows the outline for the talk, and we have now come to the topic of manual multi-step approaches, which is the primary reason for creating this web talk. This is going to be the approach that you probably most often will use. So there are several advantages of the manual approaches compared to the automatic approaches. First of all, now we can have a regression of the distal outcomes onto covariates, which is often something we want to do. And observations with missing data on those covariates don't have to be deleted. We're going to show several ways of dealing with missing data on covariates. Furthermore, direct effects from the covariates to the latent class indicators, which indicate measurement non-invariance or differential item functioning, can be included. And that's going to be a topic for Webtalk 9. Also, with several distal outcomes, the analysis with respect to those outcomes is done jointly so that missing data methodology is used. And also, more than one latent class variable can be handled, which is, of course, essential for latent transition analysis. But still, even for the manual approach, the first step is the analysis of the measurement model. And the last step now can be done by the three different methods of 3-step, which uses fixed logits from the measurement model to correct for measurement error, or BCH, which uses weights from the measurement model to correct for measurement error, or using 2-step, where the last step fixes measurement model parameters. So let's take a look at the case where we only have distal outcomes. So on slide 36, we show an example of a full model where the measurement model has been added to by 3 distal outcomes. And the distal outcomes here in this case, one variable y1 is continuous and has missing data. The second is binary with missing data, and the third is ordinal with no missing data. So now we can think about doing a joint analysis of the 3 y's in the last step and apply missing data methodology. If you only had one distal outcome y1 with missing data, which we have here, missing data methodology, FIML, cannot help you. You need more than one outcome for that to come into operation. But here now with 3 of them, and with one that especially that does not have any missing data, the missing data methodology applies. So let's then take a look at 3-step, manual 3-step, and the first step. So the first step is the same as the measurement model, as we say here, but we're adding save data of C probabilities down here, bolded. The data set is still the distal.dat data set with these variables in the columns of the data set. The variables that we're going to use are the in the first step are the 6 latent class indicators, which are categorical, in this case binary. And now we're going to use the auxiliary option once again. An auxiliary option refers to variables beyond those of the use variable option. In this case, we're only using the auxiliary option to save variables together with the C probabilities that we save at the end here. So we're not using it for automatic 3-step BCH as we did before, where we have parenthetical expressions with 3-step and BCH connected to these variables. So these 3 variables are the additional variables, the distal outcomes that we add to get to the full model in the last step of 3-step. So we save the C probabilities, which carry that file carries information, and that we will use in the last step. And we put them in a file that we call cproby here. since we're only dealing with distal outcome y's. And the save data information is given here. The save file name is cproby.dat, and then you get the variables, the use variables, plus these auxiliary variables that we had, plus the class probabilities for the 3 classes, and the most likely class designation for the latent class variable C. Most likely class for C. And we also, in that first run, get the third table that I've been talking about earlier from the Mplus output. You have the logits for the classification probabilities for most likely class membership by latent class row. So you have these logits here. We don't concern ourselves with the last category because it's fixed at 0 by default. But those 2 by 3, 6 numbers should now be entered into the analysis in the last step. So here we have input for 3-step, last step. And now the data file that we work with is no longer the original data, but we work with cproby.dat from the first step. And that means that we have a new names list, which was shown then at the bottom of, or on slide 38. And we then replace the name for the most likely class for variable C by the simple letter N. N standing for a nominal variable, but it's the same as the MLCC. So the use variable list for our final step analysis is consists of the distal outcomes plus that nominal most likely class variable called N. And since we have categorical outcomes, 2 of the 3 y's are categorical. We give that categorical list there, and we specify N as a nominal variable, 3 categories. And now the missing data is designated by a star instead of the 999 because it's a new data set. And that was shown on slide 38 as well, that missing data is now denoted asterisk or star. And since this is the last step analysis in the mixture modeling, we use starts equals 0. More on that later. And now we have a model statement for each of the 3 classes, C#1 to C#3. And we have the values that we looked at before, the logits on the previous page down here. 2.706, 0.310 for instance, 2.706, 0.310. So we give the first 2 categories of the nominal variable N and their logits, and they are fixed. So we have at here. And then we go down to the next row of logits, minus 0.121, 2.499, and so on for the last class. So those are the values that we have to give for 3-step. Now the other variables on the use variable list, y1 through y3, their means for the continuous y or thresholds for the ordinal y2 and y3 vary across the classes by default. So they don't have to be mentioned. You could mention them within each latent class here, but they don't have to be mentioned. Now let's turn to the second multi-step method, BCH. So the first step once again goes back to the original data, distal.dat, with its names list. And since the first step, we're going to use only the latent class indicators. And now we're going to once again save the distal outcome variables for the last step. And in this case, we save them together with BCH weights, the weights that BCH needs for the last step. So that's instead of the fixed logits. So the file is bch.dat. And we see the saved data here in bch.dat, the latent class indicators, plus the distal outcomes, and now plus these 3 BCH weights corresponding to the 3 classes. And again, the missing data symbol is an asterisk. Slide 43 then shows the last step of BCH. And the file name is now bch.dat, and it has its own names variable list that we just discussed. And the use variables are y1 through y3. That's the only variables in the model. You don't have the nominal indicator n, and the weights come into play in this option. Training equals weight 1 through weight 3. I just simplified the weight name from the page that we have here. Instead of BCH weight 1, just call them weight 1 through weight 3. Parenthesis BCH. And again, starts equals 0. And again, no model is needed because the y means and thresholds vary across the classes by default. We don't have any model here because we don't have any fixed n nominal variables in the BCH approach. Turning then finally to the 2-step approach, what is that like? Well, first step is the same as the measurement model. So we go back to the original data, and we have the use variables u1 through u6 again, the latent class indicators, they're binary, and we have a moderate number of starts. And now the only thing we do here that's specific to 2-step is ask for S values. You save the estimated values thereby in a file, or you have them in the output rather, but it comes out in the output and you can just copy them there. This is what they look like, shown on slide 45. So in the output you find these values for class loadeds and for the latent class indicator loadeds for the 3 classes. So you can copy this. You don't need this part, the C# part. You can copy only the C1, C2, C3 information for the latent class indicators U. And you use then the Mplus editor to replace the asterisks with at to make them fixed instead of free. And you do a global replacement where you want to make sure that no unwanted changes of asterisk occur, such as the missing data flag in missing equals asterisk, so that you may end up with that being an at instead of an asterisk, so you have to change that back. Anyway, so these are the values you take for the last step on slide 46. And note then that for 2-step, the data set is now the original data set. There's no special data set saved for 2-step. All we saved it's the measurement parameters that we just looked at on the previous page, but now with at instead of asterisk. So going back up, the use variables are u1 through u6, the latent class indicators, because they're mentioned here in the model here in the last step, and that's specific to 2-step, that you have the latent class indicator variables in the last step. You don't have that in the 3-step or BCH. And you have the 3 distal outcomes. And these are the categoricals. And you have starts equals 0. And once again, the y means or thresholds vary across the classes by default. Now, on slide 47, I point out that in the automatic approach, we got some automatic results coming out, and that includes odds ratio results. The automatic approach produces odds ratios and their non-symmetric CIs for distal outcomes. They're binary and ordinal. But with the manual approach now in version 9, we have added these outputs in the in various sections in the output, so you have them for the manual approach as well. and they're under the heading latent class indicator odds ratios for the latent classes. So it's automatically computed. Now you can do it by hand, so to speak, by using models constraint, and I showed how to do that actually in Webtalk 2, slides 17 to 20 if you're interested in the detail. Slide 48, I point out that the automatic approach produces chi-square testing of intercept and threshold differences across the classes, testing if the classes actually have a significant influence. Using the manual approach, these are found under the heading equality test of means and probabilities across the latent classes. So that kind of testing is also available with covariates when the regressions of the distal outcomes on the covariates are not class varying. So that's a way to see how the latent class variable influences, or test how the latent class variable influences the distal outcomes.